In our lesson today, we're going to extend our knowledge on factoring polynomials to solve equations. And so what I'm going to have you do here on the front, I'm going to have you practice factoring again. You're going to factor completely, starting looking for a GCF. If you have a GCF, then you can factor that out first, and then you're going to work on factoring the trinomial that follows. Okay, so when you're done, bring them on up to me and I'll check them over. In the next example, we want to know for what values of x make the following expression undefined. And so it's important to remember that when we have a 0 in the denominator, then this is going to be undefined. And so right now the denominator is defined as x plus 5 times x minus 4. And so if we have an x value here that's going to make either one of these 0, then we know that this is going to be undefined. And so looking at this first part here, well, if x was equal to negative 5, this would be undefined. Or looking at the second part, when x minus 4, if x is equal to 4, we know that this is going to be undefined. So for either one of these values, this expression here would be undefined. Okay, now in question 2 it says, what's the difference between an expression and an equation? Well, the biggest difference, or in fact the difference, is that an equation has an equal sign. Alright, that's why it's called an equation. Equations have an equal sign, and expressions do not. Okay, and so in this part here, looking at this, x plus 5 times x minus 4 is equal to 0. This is an equation. And we stated up above that when x is equal to negative 5 or when x is equal to 4, this is going to make this product equal to 0. Either makes the product equal to 0. They could both be true, making the product 0 times 0 is equal to 0, but they do not have to both be true. However, at least one must be true. And so it's important to remember the zero product property. If a times b is equal to 0, then either a is equal to 0, or b is equal to 0, or a and b are both equal to 0. In the next few practice problems, we're going to solve the following quadratics. Now, some have been factored, some haven't. So in the ones that were factored, it's going to be easier for us to figure out what the values are. But in the ones that haven't been factored, we're going to have to do a little work beforehand. In the first example, we're told that x plus 4 times x minus 2 is equal to 0. And again, to figure out what the value of x is, either one of these could be set equal to 0. So x plus 4 could be equal to 0, or x minus 2 could be equal to 0. So we're going to look at both cases. In the first case, if we subtract 4 from each side, then x would have to have a value of negative 4. In the second set, if we add 2 to each side, okay, if we add 2 to each side, then x would have to have a value of 2. So either one of these x values would make this a true statement. Okay? Looking at example number 2, 3x times 2x plus 1 equals 0. Well, again, we can break this up into two different problems. Either 3 times x is equal to 0, or we could say that 2x plus 1 is equal to 0. Looking at the first case, if we divide each side by 3 to get x by itself, x is going to be equal to 0. 0 divided by 3 is 0. And with the second example, 2x plus 1 is equal to 0, we would subtract 1 from each side, so that 2x is equal to negative 1. But then when you divide each side by 2, x would have to have a value of negative 1/2. And so either one of these, x is equal to 0 or x is equal to negative 1/2, would be a solution to this quadratic. Okay, looking at example number 3. In example number 3, notice that it's the same value, x minus 5 times x minus 5 set equal to 0. So we really only have to do this once. X minus 5 is equal to 0. If we add 5 to each side, then x has a value of 5. Okay, so I encourage you to go ahead and do 4 and 5. In example 6, notice it says 3x squared is equal to 4x minus 1. Now this is a little bit different. What we're going to want to do is try to set this side equal to 0. So I'm going to bring both of these terms over to the other side. So I'm going to have to subtract the 4x, and I'm going to add 1. And so that's going to make this left side 3x squared minus 4x plus 1 is equal to 0. And now what I'm going to do, I'm going to factor by grouping here. I'm going to take this expression here, okay, I'm going to factor it by grouping. And so I'm looking for 3 times 1 is 3. I'm looking for factors of 3 that are going to add up to negative 4. Well, I know that's going to be negative 3 and negative 1. So I'm going to rewrite this as 3x squared minus 3x minus 1x plus 1 equals 0. Okay, and so now I'm going to break this into two separate problems. I'm looking at 3x squared minus 3x, and I'm looking at minus 1x plus 1. I'm going to factor out the GCF in each case. With this first example, I know my GCF is going to be 3x. And so when I factor out 3x from each of these terms, that's going to leave me with x minus 1. And then looking at the next set, okay, negative 1x plus 1, I'm going to factor out negative 1. And that's going to leave me with x minus 1. Okay. And so now when I rewrite this as a product of binomials, I know I'm going to have x minus 1 as one of my terms. And my second term is going to be my GCF of 3x minus 1. And again, I'm going to set that product equal to 0. And so now I'm going to set both parts here equal to 0 to figure out what the possible answers could be. So x minus 1 could be equal to 0, or 3x minus 1 could be equal to 0. If x minus 1 equals 0, if I just add 1 to each side, that means that x has a value of 1. If 3x minus 1 equals 0, well, again, I'll add 1 to each side so that 3x equals 1. And then I'll divide each side by 3 so that x has a value of 1/3. So x is either equal to 1 or x is equal to 1/3. Okay, so I'm going to have you practice on 7 through 11, factor these, and then see what the value of x could be. In the next set of examples, we're going to want to factor using the quadratic formula, which is going to mean that we're going to have to review how we can simplify radicals. And so looking at this first example, it says radical 8. And so to simplify a radical, what you're going to want to do is see if that you can rewrite the number that's underneath as a product with a perfect square. And so in this example, I can rewrite the square root of 8 as the square root of 4 times 2. 4 is a perfect square. The square root of 4 is equal to 2. And so this whole thing is going to be equal to 2 times the square root of 2. That 2 out front comes from the fact that the square root of 4 is 2, and that's going to leave you with the square root of 2 left over. Okay, in example 3, we're going to do something similar. We have 12 plus or minus the square root of 160 divided by 2. And once again, underneath of the square root symbol, we're going to want to rewrite this 160 as a product using a perfect square. And so for 160, I know that's the same as 16 times 10. So I'm going to say 12 plus or minus the square root of 16 times 10 all over 2. Okay, and now when I simplify this here, I'm going to have 12 plus or minus the square root of 16 is 4, and that's going to leave me with the square root of 10 still, all divided by 2. And now when I simplify this further, each part here is divisible by 2. 12 divided by 2 is equal to 6, plus or minus 4 square root of 10 divided by 2 is equal to 2 square root of 10. And so I have two possible answers here, either 6 plus the 2 square root of 10, or I could have 6 minus 2 square root of 10 as my possible answers. Now that we've practiced simplifying radicals, we're going to see if we can factor these quadratics using the quadratic formula. And the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so we need to remember the original form of a quadratic equation, ax squared plus bx plus c equals 0. And so we're going to need to be able to pick out these values of a, b, and c. Okay, and so the first one is done out for you. I encourage you to look through that example. I'm going to work with the second example for you. And notice it says x squared minus 2x is equal to 12. Well, in order to do this, we're going to have this set equal to 0. So I'm going to first subtract 12 from each side, and I'm going to make this x squared minus 2x minus 12 is equal to 0. Okay? And now I know by looking at this quadratic that my a value is 1, my b value is negative 2, and my c value is negative 12. And so I'm going to use this quadratic equation now in order to factor this quadratic. So I'm going to say x equals negative b. Well, negative 2 is b right now. Negative of negative b is 2, plus or minus the square root of b squared. Well, b is negative 2, so I'm going to have negative 2 squared minus 4ac. 4 times a, which is 1, times c, which is negative 12. Okay? And all of that is going to be over 2a. And again, a has a value of 1, so 2 times 1. Okay, and so now I'm going to do my math. I'm going to see if I can simplify this further. X is going to be equal to 2 plus or minus, underneath of the square root symbol, negative 2 squared is equal to 4. Okay, and then minus 4 times 1 times negative 12. Negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. So 4 plus 48 all over 2 times 1 is just 2. Okay, well, continuing further, x is going to be equal to 2 plus or minus the square root of 52 all over 2. And then I'm going to look at this part here and see if I can simplify that. Well, that's going to be the same as 2 plus or minus the square root of 52 is the same as 4 times 13 all over 2. Okay, so when I simplify this even further, x is going to be equal to 2 plus or minus 2 square root of 13 over 2. And now when I simplify this even further, 2 divided by 2 is equal to 1 plus or minus, and then 2 square root of 13 divided by 2 is just the square root of 13. So my possible answers are 1 plus the square root of 13 or 1 minus the square root of 13.